everyone, welcome to lesson 8.3 in our last unit for trimester 2. Today we're going to talk about properties of equality to rewrite some of the equations and systems that make it a little harder to solve. So your aim for today is that I can use properties of equality to rewrite equations. I can add or subtract equations together to solve for x or y. So equations can be added or subtracted just like numbers can, and that's what I'm going to show you today. So let's read. There is one final way that we'll solve systems of equations, but we're not going to look at that specifically until the next lesson 8.4. So today we're going to talk about systems being important because they tell us multiple conditions that relate multiple variables or unknowns. In this lesson, we're going to experiment with systems and what we can do with them and how this affects their solutions. So we're just going to play around with properties of equality today. Remember that this lesson goes with 8.4 mastery, so this is getting you a little bit prepared for the elimination method. You've already learned the graphing method and the substitution method. So this is prepping us for the elimination method. So exercise 1 says, consider the system shown to the right and its solution 1, 5. So I know its solution is 1, 5, so that's the x, that's the y. And part A says, show that x equals 1 and y equals 5 is a solution. Well, I know that show means it wants me to plug it in and show that it works. So I'm going to do that. So I have 4x plus 2y equals 14. And instead of x, I'm going to plug in a 1. And instead of a y, I'm going to plug in a 5. And see if that simplifies to 14. 4 times 1 is 4. 2 times 5 is 10, and yes, 4 plus 10 gives me 14. So it works for the first equation. Now let's show that it works for the second equation. The second equation is x minus y equals negative 4. X is 1 and y is 5, and 1 minus 5 is negative 4. So we've answered part A of showing that it is indeed a solution. Now part B says find the sum of the two equations. Now you can find the sum of equations the same way you find the sum of numbers. You add them. But instead of just adding the numbers together, we combine like terms and add the variables together. So we're going to find the sum of the two equations first. So when I do that, I'm going to rewrite it and get 4x plus 2y equals 14. And then x minus y equals negative 4. It's really important here that the variables line up. X above x, y above y. That's super important when you're adding or subtracting equations. I'm going to put a plus sign here and make it like a normal addition problem. Now I'm going to add 4x plus this invisible 1x is 5x, and 2y plus negative 1y would give me a positive y. And 14 minus 4 gives me 10. So I have this new equation, 5x plus y. Now this new equation should have the same properties as the other two equations, meaning that the solution should be the same. So this next question that says, is 1, 5 a solution? It should be if we added it correctly. So I have 5x plus y equals 10, and instead of x, I'm going to plug in 1, and instead of y, I'm going to plug in 5, and see if I get 10. 5 times 1 is 5. And look at that, 5 plus 5 is 10. So we've now seen that you can add together equations in a system and the solution remain the same. Okay, letter C now says multiply both sides of the second equation by 2. So we're taking a little step farther and seeing how multiplying works with equality. Multiply both sides of the second equation by 2. So here's my second equation, I'm marking with purple. X minus y equals negative 4. So x minus y equals negative 4. When I multiply this side by 2, remember you're multiplying the whole side by 2, so that has to go in parentheses, so you distribute it. So you get 2x minus 2y equals negative 8. Multiplied everything by 2. Now I've got a new equation, and now it says, okay, is the 0.15 a solution to this new equation? Well, let's see. I have 2x minus 2y equals negative 8. Instead of an x, I'm plugging in a 1, and instead of a y, I'm plugging in a 5, and we're going to see if I get negative 8. 2 times 1 is 2, minus 2 times 5 is 10, and 2 minus 10 is negative 8. So it works. So we now know we can multiply an equation, we can add the two equations, and we're still going to keep equality throughout the system, which is a really awesome trick that will help us do a lot of cool math later. Okay. Now part D says, take the equation that you found in C. So here's the equation we found in C, right there, highlighting with green, and add it to the first equation. Okay, so here's my first equation right there. 4x plus 2y equals 14. So 4x plus 2y equals 14. And it wants me to add this new equation, this 2x minus 2y equals negative 8. What happens? Okay, now something cool is going to happen here when we add these together. So with my plus sign here, 4x plus 2x is 6x. Now here's where the cool thing happens. What's 2 plus negative 2? It's 0. So these are eliminated, right? They're gone. We don't actually have a y anymore, and now we add 14 and negative 8 to get a 6. And now what can we do? Now that we have the 6x equals 6, what can we do? We can solve it. Divide both sides by 6, and you get x equals 1. Isn't that what we know the solution to be? Don't we know the solution is 1, 5? We sure do. So by eliminating that variable, we've found our solution. It's a really cool trick. Finally, part D says, once you know the value of x, how can you find the value of y? By plugging in. So I'm going to take one of my original equations. So let's scroll back up. All right, let's take this equation, x minus y equals negative 4. X minus y equals negative 4. And now I'm going to plug in this x equals 1 and solve. 1 minus y equals negative 4. And I have to get y alone, so I'm going to subtract 1 on both sides. The 1's cancel out. I get negative y equals negative 5. But I've got to get rid of this negative in front of the y, so I'm going to divide both sides by negative 1. And I get y equals positive 5. And that's exactly what my solution is, 1, 5. The problem told me that in the very beginning, that it was 1, 5. And now I just solved it myself by eliminating this right here. Okay, so multiplying equations, adding equations together is like a little sneaky trick we do to try and solve a system, right? It's a little bit easier than substitution because, look, we just add them together and got this really simple equation, right? The setup is a little bit more challenging, but once you set it up correctly, the math becomes very clear. Okay, let's take a look at another exercise that shows this as well. So, this box just kind of sums up what I said. It says that solutions to systems remain solution if properties of equality are used to rewrite. So if we multiply equations, they stay equal. If the equations are added or subtracted, or the rewrite is added or subtracted, they stay equal. So we can do all of these things and still keep equality, which is really, really cool. So let's take a look at exercise 2. Consider this system shown to the right. 4x minus 3y equals 15 and 3x plus 2y equals 7. Part A says, like usual, it says show that 3, 1 is a solution. What does show mean? It means plug this in, right? Show that x equals 3 and y equals 1 works. So I'm going to take my first equation, 4x minus 3y equals 15, and plug in 3 and negative 1. So I get 4 times 3 minus 3 times negative 1 equals 15. And now I simplify. 4 times 3 is 12. Negative 3 times negative 1 is a positive 3. And 12 plus 3 is 15. So it works the first equation. Now let's try the second equation. 3x plus 2y equals 7. Remember, I'm getting my two equations from over here. So I'm using these two equations here. I'm going to plug in 3 and negative 1. 3 times 3, I'm replacing the x with the 3, and I'm replacing the y with the negative 1. 3 times 3 is 9, plus 2 times negative 1 is negative 2, and 9 plus negative 2 is a 7. So it does work. 3, negative 1 is the solution to this system, is a solution to this system. Okay? Now B says the point 3, negative 1 will be a solution to the system shown below. How can you determine this without substituting the point in? So if I look at this system right here, notice something very special about the y values. What is special about this negative 6 and 6? They have opposite coefficients. And remember, a coefficient is that number in front of the variable. So when I add these two together, what's going to happen to the y's? They're going to disappear. So I don't actually have to substitute anything at this point in. I can just eliminate the y and solve for x. That's what I could do here instead of solving for y. It's very similar to this right here on the very first exercise we did, where see how when I added the y's together, see how it's you can't really see it, but see how it's a 2 and a negative 2? That's the reason they disappeared. This is this identical situation. We just have a 6 and a negative 6 here. So now let's try it. Let's show that. So I'm going to rewrite them. 8x minus 6y equals 30, and 9x plus 6y equals 21. And let's add them together and see what we get. 8x plus 9x is 17x. The y's cancel out to 0, and 30 plus 21 is 51. Divide both sides by 17, and 51 divided by 17 is 3. So I have solved for x. The problem also says find y, so to do that, I've got to take x equals 3 and plug it in. So I'm going to take 8x plus 6y equals 30. That's my first equation right here. So I'm just rewriting this very first equation right here, and I'm going to plug in x equals 3. Oh, my pen did that thing again. Sometimes it goes into select mode instead of write mode, and I don't know what causes that. So I'm going to plug in x equals 3. So I'm going to have 8 times 3 now, plus 6y, and this will let me solve for y. What should I get for y? Well, I know that this is the solution, so I should be getting what? A negative 1. I've already found the 3. The 3 has already been found. Let's see if this gives me negative 1. 8 times 3 is 24, plus 6y equals 30. Subtract 24 from both sides. Oh, it's a minus 6y, not a plus. Sorry. Minus 6y. There we go. These cancel out, and I get negative 6y equals 6, and divide both sides by negative 6, and yep, I get that negative 1. So I found y equals negative 1, I found x equals 3, and I didn't have to graph it, and I didn't have to use the substitution method. I eliminated a variable and made a very easy thing to solve. Right? So this could be a really, really good method for you if you found graphing or substitution challenging. Alright, let's take a look at the last exercise. This is a pretty short lesson because we get more into it in 8.4. So solve the system below using the method of elimination, show the steps in your work, and show that your answer is a solution. So now this is a little tricky, and I'm going to rewrite these here because it's weird they're listed over there. So I'm going to rewrite them here, and we have a problem because do we have coefficients that are identical, that are opposites? No, 2 and x are not opposites, and 4 and 3 are not opposites. So we have to do a trick, and the trick is to turn one coefficient into an opposite of the other. Can I turn a 4 into a 3 by multiplying? Not really. There's nothing times 4 that will give me 3. But is there something times 2 that could give me a 6? Yeah. If I multiply this side by negative 3 and this equation by negative 3, let's take a look and see what happens. This top equation is going to turn into, let me do it in purple here. Negative 3 times 2x would give me negative 6x, because remember I'm distributing. Negative 3 times 4y would give me negative 12y, equals 2 times negative 3 is negative 6. Then I'm just going to rewrite the bottom equation. Oh, my phone is ringing. Hold on, sorry. Okay, I'm going to rewrite the bottom equation. 6, I'm going to leave it the same, I'm not going to change anything. Plus 3y equals negative 3. And now what I've done, by multiplying that first equation, I have now been able to eliminate a variable. Now I can add them together. These are gone. Negative 12 plus 3y gives me negative 9y, and negative 6 minus 3 gives me a negative 9. Now I divide both sides by negative 9, and easy as that, I have found that y equals a positive 1. Elimination method can save a lot of time. So, now that I find y though, what do I have to do to find x? I've got to plug in. And again, like I said, it does not matter if I use this top equation or the second one. I don't care, it doesn't matter to me. I'm just going to pick one. Let's do the first one. 2x plus 4y equals 2. So I'm going to replace the y with a 1 and get 2x plus 4 equals 2. Subtract 4 on both sides. I get 2x equals negative 2. Divide both sides by 2 to get x by itself, and then x equals negative 1. So my final answer, my solution, is negative 1, comma 1. I've done this using the elimination method. Okay. Also notice how nice and neat my work is. It's very clear to see. I want to see work like this on your mastery, right? Remember that 6.3 and 6.4 are together, so after you finish the fluency for 6.3, go into 6.4 and do that lesson before you come to mastery. Okay?